Good day guys, today we shall be designing a telecommunication mast with height 60 meters, then the basic wind speed of 40 meters per second, then the soil bearing capacity is 175 kilonewton per meter square, and we shall also be importing our model from staad pro into etabs for further analysis or detailing also. So let's open our staad pro and start the modeling. Okay, so you open your staad pro, give it any name you want, maybe 60 meters mast. Then choose the location where you want to save it. Then metric, I'm working with metric. Then job info, you can insert anything you want. Then create. Okay. So then first thing you do is to bring out your beam grid. Now this beam grid, I want to start with the base, and I want my base to be 3 meter by 3 meter, a triangular base. So I'll come put it on the XZ plane. Then okay. So first one is 3 meter. Hold Control key while you move. Okay. Then escape, come back here, then skew it to 60. Okay, then turn it on, turn it off, turn it back on again to get this. Okay, then we are finally done with this. Okay, insert node 3 meter. Okay, add new node. Okay, so I don't need this. I basically let me take your node cursor, remove this. I don't need this. So we are left with this. Now highlight it with your node cursor, then come to translational repeat in the y direction 5 meter up, then link step. Okay, I'm seeing it. So let's go to the view, let's rotate it. So this is it. The next thing we do is to add beam. So use this add beam, click it, then add beam wherever you want. See, so don't forget we are going to design it as steel, and we need to add bracing. So let's add the bracing in both directions. Okay, let's go. Then and then okay, now we are done with that. So press your escape key. The next thing is for my trusses, that's my bracing. I want to make it a truss, so I'll come to specifications. So click this beam, truss, add. So select the bracing you want to give it as truss property. Hold Control while selecting for multiple selection. Okay, so basically selected, assign to selected beams. Yes. Okay, so the next thing we do is to highlight this stuff, highlight everything with the beam cursor, translational repeat. So I'm doing 60 meters and I have 5 meters already, so I need 55 meters more. So I have 11. 55 divided by 5 is 11. So you don't need to link step. So in the y direction, then okay. So this is basically your mast. Then the next thing I'm to do is to assign property section database. So section database is basically for steel. Why define? You can also define the steel size you want. So okay, I'm using the British section. Then angle. Okay, one thing about staad pro is that if you pick any section and use it to design, it picks the best economics section for you to use. So let me just pick any random section. Let me pick this size. Okay, add, close, assign to view. Okay, yes. So basically, so you can check it in 3D in 3 ways. Either come here 3D rendering. Okay, this is your mast, or right click, structure diagram, full section, apply. Okay, so this you can also model in this way. So after applying your section, the next thing we do is to give load. Okay, so load case detail add. So the first one is dead load. You can rename it dead load. Then the next one is live load. Then the next one is wind load in x positive direction. So today I'm only going to put in the x positive and the z positive direction. So z positive direction, add, close. Okay, so for dead load I'm only adding the self weight of the mast. So self weight -1 in the y direction. So you add close, assign to view, assign. Then the next one, the live load. So you add, let me just assume a member load. Let me assume a load of maybe 3 kilonewton on it. So add close. Okay. So the next thing I do is to highlight the top. Let me view it in the isometric. I can highlight the top. Then assign to selected beams. Okay. So that's your load basically. And if you use positive direction, it will take the load up, like it will be facing, acting upward. See it? Have you seen it? So I want to make it act downwards. So you use minus. So please learn to watch your sign so you don't make mistake and analyze another thing. Okay. So the next thing I do is to add my wind load. Before I add wind load, I have to create definitions. Okay. So come here, this plus sign, click it, then wind definitions. Okay, add. So you give it any name you want, wind 1, okay, close. So under this type 1, click it, add. Now we have calculate as per ASC 7. You can also calculate like that, but I want to calculate according to BS code. So open your Excel sheet, open your Excel something. So come here. First thing we are going to, okay, let me start story. It doesn't really matter. Height, and let me say story 1, 2, 3, whatever story height it is. Then each story height, I want it to be 5 meters because we've done that 5. So the formula equals this plus sorry. So you can basically do this down whatever height you are going to. So we're stopping at 60 meters. So let me delete this ones. Then after the height, the next thing we need is the basic wind speed and basic wind speed. And our basic wind speed was given as 40 meters per second. So your Excel sheet, basic wind speed 40 meters per second. So you draw it down. Let me remove this. We don't need them. So after basic wind speed, we need our S1. So you come, okay, I have a word you can use. So to get after our basic wind speed, we need some multiplying factor S1, S2, S3 from the table we are going to get. So come here, S1, S2, and S3. So our S1, what did we see? S1 is the multiplying factor relating to the topology. So you pick your S1 again, read it. So our topology, so let's use the value of 1 for the average. Let's say 1, I'm using 1. So 1. Then what is my S2? Now, this is my table for the value of S2. So I know what I'm doing is above 50 meters. So and my topography factor, let me choose open country with no obstruction. So I'm going to focus with row 1. So all I'm going to do is to copy these values into my Excel sheet. For 5 meters, I have 0.8, 0.78, 0.78. I'm going to take a long time, 0.90. So 0.96. So what's 35? No 35. So I'm 1.9. So 55. Some are multiplying factors. Okay, so what is my S3? S3 S3 is the probability factor relating to the likelihood of the design speed. So okay, I want to use one, maybe one in every 50 years. So let me choose one, and drag it down. So what is the next thing I do is to find my design wind speed, Vs. And my design wind speed is this basic wind speed multiplied by S4 multiplied by S2 multiplied by S3. So this is the formula for basic wind speed here. Basic wind speed. Sorry, for design wind speed, sorry. So let's go back. So equals this times this times this times this. So that is it. So you drag it down. So this is your design wind speed. But don't forget, you need to convert it to pressure. So what's the formula for pressure for this is it? So WK equals 0.163 VS square. Okay, so WK equals 0.613. So this is the basic value I have. And now this is in Newton per meter square, and I want to convert it to kilonewton per meter square. So all I have to do is to divide it by 1000. So bring it here, equals this divided by 1000. Then I have so this is my wind pressure and everything. So all I do is okay, copy the heights now. Copy these heights, Control C on your keyboard, then go to your Start Pro. This is heights, so paste it there. The next thing you do is to copy your this. Sorry. So Control C again, come here, Start Pro. Go back up, then paste. Okay, so check it, then you add. So what factor? Use one, add, close. So pick your node cursor, then select, let me view from view, sorry. So select everything above the ground level. So select this with the node cursor, then assign to selected nodes, yes. So what's the next thing you are doing? You go back to your load case, you can close this one, go back to your wind load, X positive, then add, come to wind load, then WX factor 1, minimum let's say 5, the maximum 60, because we know the height of our mast is 60 meters, so maximum 60, add, close. Then the other one too for the Z positive, add wind load, Z windward phase 1, maximum 60 and minimum 5. Okay, add, close. So this are your load, this is it. Let me go to the isometric view. So this is the way the load is acting, then this is the way it's acting in the x-axis also. Okay, then what do we do next? We add load combinations. So auto load combination, you can choose any code you want to design it with. So let me design it according to American standard, then whatever table you want. Okay, see if I choose this, so then generate loading. So it has generated a loading combination. Let me use the Indian standard. Okay, so still generate loading and add, close. So it has generated a loading combination for us. So what do we do next? Next we add support. So create, I want it to be a pin support, add. So select everywhere, yeah. 3, okay, sorry. Then assign to selected nodes, yes. So this is basically our building. structure diagram, full section, apply. So this is our building in 3D. Can do it here. So this is it here. Also, you can also change the color. But for now, we are interested in the analysis and design. So there are two ways of designing a mast. This is the first way. Come here, design. Choose the code you are designing it with. And let me design with American. Let me do this. Or let me design with British. So select parameter. I'm only interested in the strength of steel for now. So design strength for steel. Okay. Define parameter. Let me change it to 460. Okay. Add. Close. Then you assign it to view. Assign it to everything, or you assign it to the materials you want to use 464. But I want to assign it to everything. Then next is check code. Yes. Fix group. So it has told you what to do. So let me add everything to it. Then group, okay, not group, remember take off. Then select, add, select optimize, add, then take off, add, close. So one thing about start pro, to choose the best and the most economic section for you when using steel to design. Okay, add, select view, yes. Steel take off, assign to view, yes. So you're basically done. So the next thing we do is analysis command, define no print, you can then add, close, then run analysis. So it's going to take a while for it to load. So while you load, you can check other things, a lot of things. You can also check the local axis, and the axis you want. Well, basically now, these are your axes, these are the local axis, and this is the global axis. Okay. So while you wait, okay, see it here. So while we wait for it to load, it takes time because quite much. Okay, so we have two warnings, one note. So let's see what the warnings are. Okay, see the warning. So it's telling us about this. Then also some wind size have changed because we chose it to select optimum and select. So it's going to select the more economical member. So let's see the results. So these are the original section we chose for it. So fill, teammate, fill. So the next thing we do is to check the steel design. So fill. So let's go to steel. So it has chosen the best section for our mast. So this is the first way of designing a steel structure. We can also design steel structure from here. Let's go. Steel. Okay, sorry. Okay. Well, basically we are done with that. Then also let's import it into Start Pro. Let's import it into etabs. Mistake. So save it. Let me save it. Okay, save. Then next we do is open our etabs. Okay, let me just use built-in settings. Okay, it's kind of done. Let me make it blank. Okay. Then the next thing you look for is come to file. You see imports and start. This is it. So next thing you go is where you saved your work. Go there. So I'm looking for a start file. I can't see it. So let me cancel it. And to bring out something for me to import. Okay, read file. So mast. Everything to save it. So we're waiting for it to read. Sorry. Let me wait for it to read. Okay, I think I need to close this. Okay, I need to close it so you can read. Okay, so I convert the data now. Then these are my informations. Okay, let's go. Okay, so let me use this. Okay. Okay. So you save it 60-meter mast, etabs. Okay, yes. So this is your mast. This is the plan. This is it in 3D. This elevation. So there are many things you can do. You come here, you can detail it. So whatever you want. Basically do all this. So anything you want, report, display, anything. Then we can also open it with Revit. So what I'm done with my etabs, to do anything you want to do, add any analysis you want to do, you are done with that. So let me go to my Revit. You come here, okay. My Revit is opening. Let me open a new structure. Okay. While wait for it to load. So now, okay. Let me wait for it to load so that I can put it on the ISM, then convert it. Okay, Revit is almost working. Waiting for my Start Pro. Kind of very heavy software and takes new models. So make sure on your Revit you have this logo Bentley, and if you don't have, you have to look for a way to install the ISM setup and go to Bentley website to download it. Okay. So while this will stop, semester mast. Yes. Okay. So you come here, file, ISM, create new repository. So while we do this, while I wait for it to load, so let me show you more about Revit. Okay, where are we? This is it. So okay, this is where it's quite a V. Let me shut down some things. Basically, we are done with this. So you choose where you want to save your masters now. So I'm saving it as 60-meter mast and ISM folder. So you save it. Okay, then you run it. So while it's running, it's loading. It's basically for things because it's only through this ISM you can import your model from Start Pro to Revit for detailing. You can also import it into other softwares, but these are the softwares we are focusing on now. So if you read this, equivalent ISM section is not found in the Start section. Please select ISM section. So you just pick any section, okay? Let me just pick this. Okay, it's almost done. It's 5%. It's a lot of work. 5%. Okay, so this is our mast. Anyway, so once you are done, you just update it. Update. You can write any comments you want. Anything. Okay. So basically, almost done. Almost. Software. So, wait. We might not be able to design the foundation today. Maybe we'll design it next video. But I say, cost of time and other things. Let me shut this one to down. Let me this. Okay. Taking time to load. check. I don't need this. %, create repository complete successfully. Okay, so what next? This is it. So nothing much. I can't close it. So I'm done with the repository now. So I click my Bentley. So what am I to do? New from repository. Okay. So it opens the structural synchronizer. So if you don't have it, maybe you need to download it from Bentley's website officially. So I choose the file I want. So start new tutorial 16-bit mass. Okay. So the next. So this is the model. So loading some change management. So this is it. Is there any changing I'm making? No. So update. Next. So what material class am I using? Let me see. Let me pick anyone. Okay, let me just pick this. Let me write anything I want. Okay. Okay. So next. So this I have to map it. So same for this. Same for this. Map it. So next. So while it's loading. Okay. Almost done. Just trying to do the detail. Okay. Finish. So yeah. So So it's basically there on your Revit, so you can see anything you want. So this is your elevation. So anything you want, you can see it. You can see it in 3D. This is your model in 3D view. Then you can cut it the section for anything you want. So basically we are done with the detailing. Then maybe in the next video we'll talk about the bolt connections or connection. So thank you for watching, and please make sure you subscribe to my YouTube channel.